Okay, so thank you very much for inviting me. Quantum theory in 20 minutes. Here's a formulation from Alex Wendt's new book, Quantum Minus Social Science, which I think everybody here should read. It's just a recommendation, you won't regret if you do. Well done, 10 years of work. So we mostly experience our actions as freely will, as if we could have done otherwise, but it is not clear how to reconcile this feeling with the ontology of modern science. So this would be the sort of scientific, why not philosophical problem of free will, but not necessarily the fault problem, but sort of reasonable problem. But then, okay, we could ask, well, what is the ontology of modern science, and perhaps in particular, let's say, what is the ontology of quantum theory? And this is a notorious question, of course. Well, we could say that to properly tackle the problem of free will, we need a truly scientific metaphysics. People here may have read Lehman and Ross, Everything Must Go, where they argue for this sort of thing, philosophy. And I would say that we need a general framework that is applied by the best theories in physics and also the special sciences. And in my view, a good candidate for such a framework is Bowman highly simplified order program, which also includes an ontological interpretation of quantum theory, which has many other names. Maybe I'm a little bit biased because I just pretty much by accident bumped into highly in my 20s, and so I got sort of stuck with these ideas, or the ideas chose me, but still, even with that bias, I do think that it's a reasonable interpretation. There's a recent book by Jean Bricmont, for example, Making Sense of Quantum Mechanics, that gives a sort of a view of the kind of a more minimalist version of the Bohm theory, just as Shelley Goldstein in Stanford Encyclopedia. What I'm focusing is the Bowman highly more exotic version, which a lot of physicists kind of ignore. But then I think if we want to solve philosophical problems, then I think the Bohm highly theory is much better than the Bohmian mechanics. Well, we'll see whether you agree. Okay, so what is it? What's the thing about the ontological interpretation? Well, it does imply some radically new ideas about the nature of quantum mechanical processes, and in particular proposes that a new type of holistic active information plays a key role at the quantum level. I think it's kind of interesting connection to the previous talk, but I won't explicitly go into them, but I think you'll associate some. And we say that this involves a radical change in what we mean by physical, and then also opening up new ways of tackling the problem of free will. And we say that information can now be seen as a new fundamental category. And Bohm himself suggesting that the sort of quantum, what we might call Bohmian quantum information, connects the physical and mental domains, as these latter have been traditionally conceived. So, some of you know there's been a big fuss about quantum mechanics for about 90 years, the interpretation of quantum mechanics, and the Bohm theory was long thought to be, kind of sadly ignored, like in Finland in the Monty Python song. However, here one of the advocates, Mike Towler, gave a graduate course at Cambridge University and had this talk, Origin of Pilot Waves, or why all of these people were wrong about quantum mechanics. The Cambridge Physics Society wanted him to change the title into Why Bohm Was Right, but he refused, and I don't know if he has any job anymore, but still, that's the this is the return of the pilot waves, and so let's see. Now we just assume that, let's say, an electron is a particle with a well-defined position and momentum. But it's not merely a particle, it's also accompanied and guided by a field psi which satisfies the Schrödinger equation. And here's just a slide. If you've read a lot about quantum mechanics, you may have read of things that is particle or field, depending on a little bit of this and that. It's not that you, of course, have heard a lot about the field which collapses into a particle or just collapses. Again, here we avoid the collapse. It's not a field that branches into many worlds, which is extremely popular even among physicists today. It's actually a particle and field, or as Bohm would like to put it, it's an inseparable union of particle and field. So he didn't want to postulate like a dualist ontology, but it's a bit of a monster still, perhaps. What is this? So here just a schematic picture from the internet. If you look, you find these pictures. Bohm, as we will see, Bohm himself said that the field has some exotic new properties and must not be thought of pushing and pulling the particle mechanically. But here we get a kind of an intuition. Here, for example, we can explain even individual outcomes. So unlike what was said in the last talk, in the standard interpretation, we cannot explain individual outcomes or make models of them, but in the Bohm theory you can. But we cannot observe individual processes. So this is, of course, this is why it's a hypothesis. But still, people used to say that even this is impossible. And so when John Bell read Bohm's 1952 papers, he said, well, he wrote later, in 1952, I saw the impossible done, because this was not supposed to be possible according to Bohr, von Neumann, and all those people. And so how do you do this? Well, it's standard practice that you can write the wave function in so-called polar form, you put it into Schrödinger equation, and then you get two equations where the real part gives you something that looks very much like Hamilton-Jacobi formulation of classical mechanics, except that there is an extra term, the Q. And that then Bohm called the quantum potential, and that's really, in the Bohm-Hiley approach, this is really the difference between quantum mechanics and classical mechanics, and you can explain pretty much all exotic non-relativistic quantum phenomena in terms of quantum potential. And here we see how it does with the two slits. The particles, if you look at the picture on the right, the particles would come toward you from the holes. In Newtonian physics, Q would be 0, or in the classical domain, and they would come in straight lines. But here, we have a situation where quantum potential is not negligible, and we get this mountain-like thing. You can think of potentials like mountains. To climb up, you would need a lot of energy. And if you look at the trajectories, you can see that no little thingy goes where the mountain is very high. And so this is how you actually then get the trajectories. And then where a given electron will end up depends on where it started out. So it will start out as a hot filament, and there would be sort of a suitable random statistical distribution, which then gives you the correct statistics in your experimental results. But again, I said these are hypotheses. They are actually at University College, Basil Hiley is currently measuring average trajectories with helium atoms, and so they're doing the two-slit with so-called weak values, where you get kind of closer also to experimental verification, but it's still a lot of controversy about what those results mean. Okay, let's get to the philosophical exciting part. But as well, how does the quantum field influence the particle? If you read papers other than Bohm and Hiley, they will just say, well, the field is pushing the particle. They just say, well, let's not worry about it all. Let's just call it the law or something like that. But even Bohm himself felt that it's not easy to say, but they actually ended up proposing that this quantum field carries information about the structure of the environment, such as whether one or two slits are open, and then it literally informs the movement of the particle. And here, this is, again, you can see the connection of the previous talk. In this sense, information would be a significant causal factor in the quantum domain. Now, why did they bring in this kind of notion of information here? Well, if you look at the mathematical expression of the quantum potential, you'll notice that the amplitude, this is the amplitude of the field, it appears both in denominator and numerator, and then it can cancel out. It doesn't matter, size doesn't matter here, as a small wave can have exactly the same effect as a large one, and this means that the quantum potential can be strong even if the amplitude of the quantum field is very weak. And this is one way understanding a particle have no locality. And you know the delay choice business, that if you do something at the other part of the universe, you can feel it here. This quantum potential can explain those kinds of no local quantum effects, even though it is counterintuitive, as Håkan pointed out. So what matters here? Well, if you look at it, then you see that the Q depends on the second spatial derivative of R, which reflects the way in which R changes, or the form or shape of the wave. And note that it depends only upon the form of the quantum wave. So the quantum wave is not pushing and pulling the particle mechanically. And here is something we could call informational causality. That we are teaching our students that formal and final causes were killed by the great scientific revolution. So we were left only with efficient and material causes. But here we are bringing in some notion of formal cause in fundamental physics. So that's again one of the reasons why I got stuck with the idea 30 years ago, I guess. Okay, so, and you could say well, it's a radical proposal, because we're saying here that this type of active information ought to be acknowledged as a fundamental, perhaps the fundamental category of physics. And they acknowledged this already back in '83, that this idea is far more subtle and dynamic than any others that have hitherto been supposed to be fundamental in physics. And of course, that now after like 34 years after they wrote this, people still, this is not still sort of generally accepted. It of course proves that they are entirely correct in what they're saying, so maybe not. Okay, so let's look at a little bit more of the idea of the active information. Here, Bohm wouldn't want to make it all non-material or non-physical, to say this information non-physical. He would still assume that there is some form of matter or energy that, if you like, is the medium for this active information. We just don't know yet what it is. We kind of discovered the structure before the furniture in the Lehman-Russell terms. So there's a form having very little energy that enters in that directs a much greater energy. And so the activity of the greater energy is given a form similar to that of the smaller one. And we get many analogies. The one they liked, these analogies are dangerous because they're not literally the same as the quantum situation, but they can be useful. So for example, if we think of a ship on automatic pilot being guided by radio waves, the effect of the radio waves is independent of their intensity and depends only on their form, and they're not pushing and pulling the ship, right? The essential point is that the ship is moving with its own energy, and the information in the radio waves is taken up to direct a much greater energy of the ship. And in the same way, the electron moves under its own energy, whether it's the rest energy or vacuum. I mean, they were speculating various possibilities. And then the information in the form of the quantum wave directs the energy of the electron. You can think of other examples. This is not uncommon. I mean, the DNA, again, the DNA molecule guides protein construction. It's the form, the order of the DNA that matters there. Or even in human subjective experience, when you're reading a map, an information content builds up. You don't have to eat the map, you actually abstract the form, and you know where you are, where you want to go, and then you choose your trajectory accordingly. And of course, we raised the question about the relation between channel information and active information, where the key point is that the active information is we could think of as an objective commodity, as Fred Gretzky would say. It's information for the electron, just as the DNA is information for the cell. It's not information for us. But the newspaper is information for us. But still, this is a difficult point for many people who know this, but it just, once you get it, it's kind of obvious. Now, okay, 5 more minutes and let's talk about free will. Here, researchers worry that there is no room for genuine free will in the physical world. And now we've seen that Bohm and Heide are suggesting that information is a fundamental aspect of the world. Bohm used to call meaning, a key factor of being. in this sense. And we could raise questions, well, is there some way in which what we call free will would be connected to active information, and perhaps to explore that we could ask in what sense, if any, is active information mental? And Bohm used to make this sort of characterizations, the difference between activity of form and activity of substance, and he would claim that the essential quality of mind is the activity of form rather than of substance. So when we read the newspaper, we don't actually have to eat the paper, but we just abstract the form of the letters, and then these forms give rise to information content in the reader, and this content is manifested actively in her subsequent activities. So if it says in the newspaper that you get free iPhone 7s by doing this and this, so of course you immediately give all your bank details or credit card number. But that's the and they're more generally the side of meaning as activity. It may be that Bohm got this from William James or something, I don't know. He didn't reference it very well, but it's probably again an idea that's been in the air. The idea is that meaning is not an ethereal, abstract quality, at least psychologically. Typically, meaning gives rise to activity. And now, perhaps sadly for free will, this often happens automatically, unconsciously, and rapidly. And there's an example that would illustrate this. If you think of you're walking in a dark night, you've just heard that there's a dangerous assailant out there to kill you, so you might become exceptionally watchful and alert. You see a suspicious-looking shadow, and if your brain mind interprets this as the assailant, meaning danger, there's a powerful physical chemical activity. Adrenaline will flow, and you get this. And then later on, you see that it's merely a shadow, meaning no danger. You start calming down. Shakespeare got the first part of this knowledge, but he didn't discuss the psychosomatics. This is the Midsummer Night's Dream. And Bohm would say that this kind of response to information is extremely common. And in this sense, information is active in not just in an abstract way mentally, but also physically, chemically, electrically. So here we have this idea of downward way, how information and meaning acts downwards in a signal-summoning activity. Now, we could say that even if we then ask a question about free will, because a lot of the stuff that we're talking about seems to happen just like automatically. But even our conscious reflection involves information and meaning. And now we could say, well, perhaps we make our free decision in such reflection based on what things mean to us. Von Richt would say that free will is actually determined by reason. So this is why I haven't talked about quantum indeterminism or quantum randomness, because that doesn't really capture what we mean by our free decisions. But perhaps some sort of spontaneity would be still desired for free will. And I just briefly say, we ask, well, how could a conscious will move the body? What Bohm kind of proposed that it's quite natural to extend the quantum ontology. So just as there's a quantum field that guides the particle, there can be a superquantum field that guides the first order quantum field, and so on. And we then assume that the information contained in our mental states is a certain part of this hierarchy of fields. You could do, I've been trying to do a higher order theory of consciousness at this context, but I won't talk about that. So anyway, through the hierarchy, mental states could then guide material processes by reaching the quantum field of the particles and fields in the brain. And of course, now you could ask, how exactly? And we could hear the quantum brain theory to the rescue. Just an example from Penrose and Hameroff, where this is their answer. I won't read the whole thing, but it's just an example, from their recent review paper, where this is for the Penrose-Hameroff scheme. They speculate that where the strategic site for coherent quantum states in the brain would be, and also they speculate about the possibility of large-scale quantum state in the brain, and of course a lot of people have criticized these ideas and that they have been able to reply, and so So anyway, that's a kind of still, maybe it's the same as when Faraday was speculating about electromagnetics in the 1800s, you know, we make it a better theory. In my own thing still, that is kind of stuff away. But anyway, here we go. Here is anyway the summary that this scheme gives a key causal role to information at the quantum level, and then if free will spontaneity is possible at higher levels of information, then the hierarchy enables free will to guide visible action. Thank you very much.